So here I'm going to do a Leaving Cert Pass paper question on trigonometry. It's from 2018. It's paper 2, question 4. We're asked to find all the values of x for which cos of 2x is equal to minus root 3 over 2, where x is between 0 and 360 degrees. Okay, so this is our standard unit circle question. For more on the unit circle, look back to the website and look to the intro videos. So the first thing we do for answering this type of question is we look for a reference angle. So for our reference, we've got inverse cos of root 3 over 2. Okay, we know it's minus root 3 over 2, but minus root 3 over 2 is just going to give us an idea of what quadrants we're dealing with when we look for our actual angles, our values of x. So for this now I need to go into I can put into the calculator, or you can just simply look it up in the log tables. So we'll do that now. So in the log tables we're looking for cos, and we're going to keep going across from cos until we hit root 3 over 2. That gives me a reference angle here of 30 degrees, or pi over 6. Depends what we want to deal with. If we're dealing with degrees, then we're going to use 30 degrees. Remember, if the question is asked in radians, you can always just work with degrees and then convert to radians at a later stage, knowing that 2 pi is just 360 degrees. So we know now we're dealing with 30 degrees as a reference angle. So we'll just move across back to the paper. Okay, so our reference angle is 30 degrees. The next step in the process is to have a look at our unit circle. And if we start here at 0 degrees, if I go all the way around the unit circle, that angle there is also 360 degrees. Okay, so from my unit circle, this is the first quadrant, this is the second, this is the third quadrant, and this is the fourth. Okay, what we're going to look at is we're going to see when is cosine a negative value. So it's minus root 3 over 2 is what we're dealing with. So I think back to cast, C-A-S-T, and I know it starts from here, so when I'm filling in my unit circle, C-A-S-T, that tells me which trigonometric property is positive in each quadrant. And in the first quadrant, they're all positive for A. In the second quadrant, only sine is positive. In the third quadrant, only tangent is positive. And in the fourth quadrant, cosine is positive. So we're looking for the quadrant in which cosine is negative. And the quadrant in which cosine is negative is here, quadrant 3, or here, quadrant 2. Because in those quadrants, sine and tan are the only ones that are positive. So we know we're dealing with quadrant 2 and quadrant 3. So we look to our 30 degrees and we say, well, what angle does 30 degrees represent from the positive sense of the x-axis, okay, when I have 30 degrees in the second quadrant? So I'm just going to draw a line here, and you wouldn't need to go through this much detail fully when you're answering this, but I'm just drawing a line. I'll get rid of the ruler. This angle here is 30 degrees. So what I'm really asking myself is, what is that angle there for? Okay, the one that's highlighted in green. Well, if the reference angle is 30, because I've got a straight line along the x-axis, that entire green line is going to be 180 minus the 30. So in the second quadrant, we have 2x, because that's what we're asked for here, is equal to 180 minus 30 degrees. Now we'll just add in our general polar form, which is n times 360, or 360 n. We'll just keep our degree sign in for now. So just answering this one out in full, 2x is equal to 150 degrees plus 360 n. So therefore x is equal to 75 degrees plus 180 n. I've just divided everything by 2 there. So all you do now is you let n equal to 0, and we have x equal to 75 degrees plus 0 times 180. We let n equal to 1, x equals 75 degrees plus 180 degrees times 1, and that gives me a figure of 255 degrees. If I let n equal to 2, let's just say n is equal to 2 here, I'm going to have 75 degrees plus 2 times 180 degrees, which is 360. So if you think about it, that'll be 435 degrees. So starting here, 435 degrees goes around the unit circle once and goes around again till I hit 75 degrees again. So I actually repeat the n equal to 0 result. I don't need to go past n equal to 1. All it means I've done an extra revolution of the circle there, but that doesn't matter. Okay, we're only getting answers here between 0 and 360. Okay, for quadrant 3 now, up the top right, let's look at this. Here, we're going to follow the same strategy. So 2x equals, now let's get the ruler out and see what does 30 degrees become here. Well, if that's 30, then what we are interested in is what that angle there is from the positive sense of the x-axis. So I'm going to start here and I go all the way around through quadrant 1, all the way around through quadrant 2, and there to that angle. So I'm interested in that entire angle there, which is going to be my 180 degrees plus the 30 in the third quadrant. So 2x is equal to 180 degrees plus 30 degrees, and then plus our n times 360 degrees. So therefore 2x equals 210 plus n times 360. X is equal to 105 plus n times 180. We do the same thing we did here. We're going to let n equal to 0. X equals 105 degrees. We let n equal to 1. X equals 105 degrees plus 180 degrees, which is 285 degrees. So the 4 values of x is equal to 75 degrees, 105 degrees, 255 degrees, or 285 degrees. So what we're going to do now is have a look at the next question. And let cos of a equal to y over 2, where a is between 0 and 90 degrees. Write sine of 2a in terms of y. Okay, so it says let cos of a equal to y over 2, and a is between 0 and 90. So what we're going to do is I'm going to just kind of have a look at our trigonometric ratios here, because we know that if, let's say that angle there is a, if cos of a is y over 2, well, we know that in a right angle triangle, cos relationship is the adjacent over the hypotenuse. So we're looking for sine of 2a in terms of y. We know that the sine has to do with this unknown here, which we can call x. Now I'm only introducing x so that I can get this in terms of y. Sine of a is equal to opposite over hypotenuse, which is x over 2. But I'm not allowed to have x in my answer, so I need to see what is x in terms of y, because it's asking me in terms of y here. Using Pythagoras, for that right angle triangle there, you've got, I'm going to do this on the side, 2 squared is equal to x squared plus y squared. I'm just going to change that around a bit. X squared is equal to 4 minus y squared. X is equal to root 4 minus y squared. So sine of A actually is equal to root 4 minus y squared all over 2. We're not asked for sine of A, we're asked for sine of 2A. So here we've got our double angle formula that we need to go to the tables for. So sine of 2A. So we're just going to put up the tables now. We can see that for the double angle formula on the right hand side here, sine of 2A is equal to twice the sine of A times the cos of A. So if I just write that here, sine 2A is equal to twice sine A times cos. So it's going to be twice sine of A times cos of A. Well, sine of A is 4 minus y squared all over 2 times cos of A. And the cos of A was given in the question, it's just y over 2. So our answer there is going to be, if I expand out the brackets here, well, that 2 will just cancel with that 2. So our answer, if I just write that here, our answer becomes y times root 4 minus y squared, and I've cancelled my 2's there, all over 2. At times we're going to need to introduce a new variable, and I did there called x, but I got rid of x straight away because I just needed to see what it was in terms of y. So when you're dealing with trigonometric functions, try to use the right angle triangle. You're going to be using Pythagoras and things like that to help you.